Hello and welcome to trigonometric functions of any angle. So the idea here is that instead of just restricting ourselves to the first quadrant or to just mere right triangles, we're going to start to move all the way around and have all four quadrants available. Now the basic premise here is still going to be that the cosine of any given angle is going to be its x value, the sine is going to be its y value, but because we can't restrict ourselves strictly to the unit circle, it may be better to think of it in terms of the SOHCAHTOA mnemonic, meaning the opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So here's what I'm talking about. In general, if you're in the first quadrant, then for some angle theta, right, there's going to be an associated x value and a y value, and there's going to be some radius, right? Now, please bear in mind that x squared plus y squared has got to equal r squared. Remember the Pythagorean identity, the cosine squared plus the sine squared equals the radius squared, or 1 if it's the unit circle. So what this means is that the sine of theta would be, well, y over r, the cosine of theta would be x over r, and the tangent of theta would be y over x. Now, if you look carefully, that's just a right triangle, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So it gets mildly tricky, but only mildly tricky, if you do the same thing for some angle. We're defining this as a direction, so some angle theta, such that we end up in a different quadrant, like let's say the third quadrant here. Now, there's still an associated radius, that is length of this, there's still an associated y value, and there's still an associated x value. So it turns out that for this particular theta, the sine is still the y value over r, the cosine is still the x value over r, and the tangent is still the y over the x. Now, the only real difference is, depending on which quadrant you're in, you may end up with positive or negative values of y or x. R being this radius, and remember it's the product, it's a sum of the squared, so r is always going to be positive, okay? The y and the x to get you into different quadrants can be. So what this means is that you're going to have different values for sine and cosine, and then any attendant function. So I'll do this out for one of these quadrants. So when we're in quadrant 1, then we know that all of these things are indeed positive, so they're all greater than 0, right? Because we're in the first quadrant. So for the second quadrant, what happens? Well, we know in the second quadrant, we know that all the points have a negative x value and a positive y value. So what does that mean? Well, it means that anything that's based on the value of x is going to be negative. So for instance, the tangent or the cosine. So you're going to see the cosine is going to be less than 0, and the tangent is going to be less than 0. The sine will still be greater than 0. Okay. By the way, this means any reciprocal identities. So like the secant is also going to be less than 0, and the cotangent is going to be, of course, less than 0. And let's see, what is the, so that would be I can remember this, cosecant would be greater than 0. So depending on what quadrant you're in, right, so if you're here in quadrant 3, where they're both negative, negative x and negative y, then that means that the sine and the cosine and the cosecant and the secant are all going to be less than 0. But oddly enough, because both are negative, the tangent and the cotangent will be greater than 0. So for instance, if someone tells you they're looking at something where the tangent is equal to 5, let's say, then you know that you're either in quadrant 1 or 3, because they're positive values, right? And of course, then quadrant 4, we discover that, or hopefully we know that positive x and a negative y would mean that the cosine and of course then the secant are going to be greater than 0, but the sine, cosecant, tangent, and cotangent are all going to be less than 0. If you think about it, it makes a lot of sense. Okay? Pretty hard. You don't have to memorize it per se. You can kind of figure it out. Reference angles. So reference angles are, well, they're referring to, more specifically, and this is used pretty much exclusively in the first quadrant. That is, if you think about any given angle. So if I'm looking way over here, and let's say I'm looking at this angle here, which I'm going to boldly say is, how about 5 pi over 6, right? So just shy of pi, which is here, right? So 5 pi over 6 is this angle right here, right? But if you look carefully, there is some sort of reference angle. That is, if you form an angle, so if you have to form an angle, the acute angle that is relevant, that is, I'm sorry, not relevant, is related to, is formed by the x-axis and the terminal side of the angle. So we're looking at formed by the x-axis and the terminal side of the angle. Remember, the terminal side of the angle is just the side that it ends on. Side of angle. That will correspond to some angle in the first quadrant. So if we're looking at theta, right, being this, then this blue theta here, let me just move this out here a little bit. Your book likes to use prime, so sometimes for a reference angle they'll use theta prime, right, to indicate the reference angle. But in that case, it would be whatever this angle is. So easiest way to do this is, of course, we have pi here, would be this full distance. What's pi minus 5 pi over 6, which is the same as, remember your fractions, 6 pi over 6 minus 5 pi over 6, which is equal to pi over 6. So we'd say that the reference angle for this would be, reference angle, there we go, would be pi over 6. Why is this helpful? Because it means that all of these angles, assuming that they fall on one of the special angles, and this is principally where we use this, right, is going to be, they're going to be related to pi over 6, pi over 4, or pi over 3, which means you're looking at your root 3 over 2 and 1/2, or your, sorry, number 1, oh, you're just going to get erased, or you're looking at your root 2 over 2. What it means is you can memorize less, because you only need to know these by heart, and then everything else is going to be related to that somehow. The big difference here in this quadrant, we know that anything involving the x, right, so the cosine or the tangent or the secant or the cotangent are going to be negative in that case, but they're still going to be related by these same values. Okay? Now, finding the third side. I've already basically told you how to do this, but if you are given an angle where the point, let's say negative 6, 2 lies in the terminal side, then you can do things like find the sine, cosine, tangent. So what this means is you're looking at an angle where it's negative 6 this way and 2 this way. So you're looking at some angle where that point, negative 6, 2, is on that terminal side. Now the terminal side, really is a ray, so it could go on forever, but this point is definitely on there. So what does that give you? Well, it gives you enough information to be able to fill out what the x and y values are of, so this value here would be 2, and this value here would be negative 6. Now, in this case, that means then you can calculate this, which would be the square root of 2 squared plus 6 squared. Remember, negative 6 squared is still going to be positive, so my advice is to treat it as positive. So that's 36 plus 4, so that'd be root 40. And of course, because we're good mathematicians, we're going to go ahead and pull out a 4, which is 2, right? And so the square root of that, so it's going to be 2 root 10, right? that means that we can actually do calculations for, so here's that angle, theta, right? If I wanted to find the sine of this given theta or the cosine of the theta, I could just use the fact that I've got the sine would be 2 over 2 root 10, which, by the way, is 1 over root 10, which, of course, we rationalize as root 10 over 10, yes? The cosine would be negative 6 over 2 root 10, aka negative 3 over root 10, or negative 3 root 10 over 10 when we rationalize it, and so on. I mean, the tangent would be easier. It'd be 2 over negative 6, right, or negative 1/3. You can take the reciprocal of these to find the cosecant, secant, and cotangent, if you will. So the key thing about finding the third side is the dreaded Pythagorean theorem. In certain cases, you may know something about the hypotenuse, like if someone tells you that the sine is equal to, so the sine of this angle is equal to, I don't know, how about 4/5, right? That tells you that the opposite side, or the y value, is 4 and the hypotenuse is 5, which means you can then know that you're looking at this being 5, this being 4, and you can calculate this by taking 5 squared minus 4 squared and then taking the square root, or you can recognize that this is a 3, 4, 5 right triangle, so you know that value is 3. And then you can find all these different ratios out. So that's what that means by finding the third side. And yep, this concludes what we're going to talk about related to section 4.4.